All right, here we go. We're starting with problem number 12. So exciting. I'm excited. Remember when we're graphing log functions, just like in our notes, Ms. Logus gave you this general form, all right? Log base b of x, okay? And always on our, I don't like using the word always, but when we're talking about our points and our parent function, all right, I'm going to see these 2 points, 1, 0, and whatever my base is, so b, 1. All right, and my vertical asymptote is x equals 0 in the parent function. Okay, so we're going to use those 3 pieces of information to help graph our new function. Okay, so to graph this function, well, my base is 4, so the parent function I would have 1, 0 and 4, 1. Well, now what does this 2 do? This 2, all right, if it's inside, we do the opposite, so I go left 2 minus 1 means I go down 1. Well, if I take 1, 0 and move it to the left 2, that becomes negative 1, 0. Whoops. That becomes negative 1. If I take 4 and move it to the left 2, I get 2. Okay, I'm going to make my down, let's make it purple. So if I shift my graph down 1, 0 becomes negative 1, and this becomes 0. My vertical asymptote, if it's x equals 0, and if I'm shifting my graph to the left 2, then my new vertical asymptote should become x equals negative 2. Negative 2. If my original was x equals 0. Alright, so I'm shifting that everything to the left 2, which includes my asymptote. If I shift it to the left, if I shift it to the right 2, alright, this would have been x equals positive 2. Okay, so if I think about my function here, alright, first of all I'm going to graph that negative 1, plot that point, and then 2, 0, alright, and plot my vertical asymptote at negative 2. It's hard to write on this, so you know what, you're just going to have to give me a break here, give me some pass. Alright, so I got that x equals negative 2. Again, these are rough sketches. And it goes off. See you, bye. Okay. So our domain, remember, if we look at this function, my graph is never going to cross. I cannot intersect a vertical asymptote. So I'm looking at all x values that are greater than negative 2. And since it's a vertical asymptote of negative 2, I am not going to include negative 2. So I go from negative 2 to infinity. Alright? The range is different. Okay? This is going down towards negative infinity. This is slowly increasing up. So my range is going to be negative infinity to infinity. Okay? X-intercepts, X or Y or both. Alright, for this particular one, I'm going to have an X-intercept. We just found it here by shifting our points. No, oh, this is the one that jumps. Holy buckets. So my X-intercept is going to be 2, 0. Wow. Alright. My y-intercept, okay, I can get this by plugging in 0 in for y, for x. I can also look at my calculator, look at the table function by plugging this into the calculator and pressing second graph. Alright. What I end up getting is 0, negative 1/2. Again, plug it in for x, alright, or plug it into your graphing calculator and look at the table. I pull up a graphing calculator here, but I don't have that software. So got a battle. Alright, to get the table, you press second graph. Second graph. Okay? Number 13. Suppose 2750 is invested at a rate of 6% compounded quarterly. Alright, what is the balance after 7 years? Okay, how much more money would you earn if your interest was compounded, or if your interest in this account were compounded continuously? Okay, so let's take care of the first question first. What's your balance compounded quarterly? So compounded quarterly, I'm going to use this equation. A equals P times 1 plus R over N to the n times t. Okay? Remember, p is my principal value or my initial deposit. I deposited $27.50. 27. 1 always stays 1. My rate, you want to write our rates as decimals, so 6% becomes 0.06. So 0.06 over the number of times compounded per year. Well, if it's compounded quarterly, quarters, think quarters, there's 4 quarters in a dollar, so that's 4 for n. All right. Again, n times t, t is 7. All right. After plugging this into my calculator, you should arrive at the number I got, 4172.36. Be careful with your parentheses. All right, when you plug this into your calculator, you want to put a parentheses here and make sure you're doing, I have a single here, single there, and then I need to follow it with a double, 2 there. All right, and then this would be to the 28th power. Okay, so just be careful with how many sets of parentheses you use. Okay. All right, let's talk about continuous. Compound and continuous, I use PERT. A equals P, it's that exponential, times E, which is always going to be E, if I could just write it out, to the R T. Okay, well, what's our investment? So A equals our principal. Our investment was, our initial investment was $27.50. The E stays E, always. R, our rate, was 0.06 times T, which was 7. Okay? If you plug this into your calculator, you can plug it all in at once. That's totally fine. Okay, make sure this is in parentheses, 0.06 times 7. All right, I got, what did I get? 41. I just never can remember to write the 1, huh? 4185.39. Okay. So this is not my answer. Remember, this says how much more money would you earn if your interest was compounded continuously. So I need to subtract. I need to take my continuous the amount of money I earn when I have it compounded continuous, so my number in red, and subtract. Oh my gosh, I'm gonna lose my mind already. Already gonna lose it. And subtract the number in blue, minus 4172. Holy buckets. 4, 1, 7. Sorry about that. I had to pause for mental health. So we did 4185.39 just to gather myself. All right, minus 4172.36, and I got 13.03. All right, woosah. Here we go. 14. All right, this is a review of complex numbers. Okay, remember when I have an I have I to the 11th. I want to think about how many times I can get I to the 4th into that. Because remember, I is the square root of -1. I squared is -1. I to the 3rd is -I, and I to the 4th is I squared times I squared, which is just 1. That is why we want to put everything in terms of 4s. All right, so I want to think about how many groups of 4 I can get into I to the 11th. Well, I to the 11th is really I to the 4th times I to the 4th times I to the 3rd. Now, you could do this part in your head. That's totally fine. I'm just showing. I just want to write it out for you so you can see where my thought process is at. So this is 1 times 1 times -I. So this term right here becomes -6 times -I which gives me 6. This becomes 9 times the square root of 16 is 4, so the square root of negative 16 is 4i. Sorry, there should be 6i. Alright, well, 9 times 4 plus 36i, and the 2 just comes down. Okay? I want to combine my like terms. Alright, so I combine my like terms and always write my non-complex number first. So I get 2 plus 42i. You always want to write it as a plus bi. Alright, so I want my complex number to come second. Okay, letter B. Here we go. Alright, I do not want i's on the bottom. I don't want any imaginary numbers in my denominator. So what I do, I multiply the top and the bottom, my numerator and my denominator, by the conjugate. Remember, our conjugate, all we're doing is switching the sign of our problem. Our problem is the imaginary number. So since it was negative here, I multiply it by positive. Alright, think about it like this. Every imaginary number has a buddy, plus or minus. Well, I have the minus, I need the plus. Okay, so I FOIL on top. I'll do that all in red here. So I have 10 plus 4i, and I got 15i plus 6i squared. Alright, my denominator, I can FOIL this out. I got 25 minus, or excuse me, plus 10i minus 10i minus 4i squared. Okay, remember I squared, just like we talked about here, is negative 1. So this becomes, the i's go away, the I squared drops out. This is minus 6. Okay, I squared drops out. This becomes plus 4. Alright, combine my like terms on the top. Oh, look, these also cancel. Combine my like terms on the top. I got negative 6 and 10. 10 and negative 6, so I have 4. 4i and 15i gives me plus 19i. Combine my like terms in my denominator. I have 25 and positive 4. 25 plus 4 gives me 29. Alright, I'm actually going to pause this video, or stop this video here. Okay, so that is 12 through 14. I'll pick up with number next one, 15, on the next video. Alright? See you bye. See you bye.